Adding and subtracting rational expressions. Our objective is to add and subtract rational expressions, as well as simplify complex fractions. Why learn this? You can add and subtract rational expressions to estimate a train's average speed. Let's look at adding and subtracting rational expressions with like denominators. Recall back to when you were adding and subtracting your simple fractions, maybe 1/2 and 3/2. You would keep the denominator the same, and then you would add your numerators. It's the same principle here. So when the denominators are the same, we are simply going to combine like terms in the numerator, or add them together if you will. So we're going to be left with this x plus 3 in our denominator, and then our numerator, we have 3x and 2x, which make 5x, and we have a -4 and a +5, which are going to give you +1. And there you have it. You have added fractions. Now, try subtracting. So the same principle applies. The denominators are the same. So now you're just going to subtract. Keep in mind, you're subtracting every value. So when you subtract, you want to make sure you're subtracting 4x and you're subtracting 4. So that leaves you with x squared plus 2 on the denominator. And then in the numerator, we have 2x minus 4x, which leaves you with -6x. And then we have -1 minus +4. So -1 minus 4 leaves you with -5. And that's how you add or subtract rational expressions with like denominators. Now let's look at least common multiple of polynomials. Factor each polynomial completely, just like we did in previous sections. Write any repeated factors as powers. For example, x to the third plus 6x squared plus 9x is the same as saying x times the quantity x plus 3 squared. Because when you factor it out, you end up factoring out an x, and then you have x plus 3, x plus 3. So you have 2 of these x plus 3's. Hence why you're going to write it as a power. List the different factors. If the polynomials have common factors, use the highest power of each common factor. Let's practice. So let's look at the least common multiple for a. I think it's helpful to do your numbers separate from your variables when you're looking at monomials. It's a little bit different when you start getting to trinomials and binomials. So what's the least common multiple of 2 and 3? Well, the least common multiple would be 6, because that's the smallest number that both 2 and 3 can go into. So now, just like it's stated back here, list the different factors. If the polynomials have common factors, use the highest power of each common factor. So we want the highest power. Which one's got the highest power? X to the third or x to the fifth? Well, x to the fifth does. And do the same things with the y. Alright, so in B, we have 2 trinomials. So we want to make sure we factor each part completely. So we want 2 numbers that multiply to give you -4, but when you add them, you get +3. And then in this one, you want 2 numbers that multiply to give you 2, but when you add them, give you -3. So that's going to be -2 and -1. So therefore, your least common multiple is going to be x plus 4, x minus 1, and x minus 2. The x minus 1 is in common in both of them, so you don't need to write it twice, you just simply write it one time. Take a moment and pause the video and try C. When you return to the video, the answer will be revealed below. And there you have it. So now let's put this to good use. This helps us when adding rational expressions. So, when our denominators are not the same, we need to make them the same. So we need to factor our denominator here. So we have 2 numbers that multiply to give you 2, but when you add them, they give you 3. So this one has an x plus 1, but it's missing this x plus 2. So you need to multiply the denominator and the numerator. Whatever you do to the bottom, you have to do to the top. You can't just do it to one or the other. So that leaves you with x minus 1 over x plus 2, x plus 1, and then we're going to add that to x squared plus 2x, all we did was distribute there, over x plus 2, x plus 1. And from there, it should look like what you were doing before. You have common denominators, so now you can simply add your like terms. So we're left with x squared plus 3x minus 1 over x squared plus 3x plus 2. Notice all I did was put this denominator back into its original form because that's what x plus 2 times x plus 1 equates to. And there you have it. Try this next one on your own. When you return to the video, the answer will be revealed below. Alright, so many of you probably got to this point here, where you have added your like terms and you kept your denominator the same. However, in this problem, you can go one step further. Notice what happens when you factor this trinomial. So you want two numbers that multiply to give you negative 18, but add to give you negative 3. So we want ourselves a negative 6 and a positive 3. Well, notice you can now simplify. We've got x plus 3 on the top and the bottom. So all you're left with is x minus 6 over x minus 3. Now let's try a subtraction problem. You do the same thing you were just doing when you were doing the addition. However, when you simplify, as in you combine your numerators, make sure you subtract each piece instead of add them. So when you return to the video after trying this one on your own, the answer will be revealed below. So we rewrite it so that we have our factored denominator here. Then we can notice that we are missing an x minus 2. So we multiply our numerator and denominator by x minus 2. When we do so, we have to make sure we distribute across to everything when we're multiplying, just as you see here in green. That's going to leave you with x squared plus 2x minus 8. Now that you have common denominators, just like you were adding before, this time you're going to subtract. And remember to subtract every piece. Okay? So you have 2x squared minus x squared, and then you have minus positive 2x, and then minus negative 8. So negative 16 minus negative 8 gives you negative 8. Last step here, we can factor this top. So we end up with x minus 4 and x plus 2. Cross out our common factors here, and then that leaves you with x minus 4 over x minus 2. Some rational expressions are complex fractions. A complex fraction contains one or more fractions in its numerator, its denominator, or both. Examples of complex fractions are shown below. So we have like x plus 2 over 3 divided by x. Or we have 1 plus 1 over x divided by 4x plus 5. So notice how you have fractions inside of fractions. That's the way I like to think about it. So let's try simplifying these. So we're going to simplify 2 divided by x plus x divided by 4, that quantity divided by x plus 1 divided by x. Let's start by rewriting this so that way you can see things horizontally. So we have 2 over x plus x over 4. That quantity is going to be divided by x plus 1 over x. So let's start with parentheses, following our order of operations. And to add these together, you need common denominators. In this first one, you're missing a 4, and the second one, you're missing an x. So we're going to multiply by 4 and by 4, and then by x and by x. That's going to leave you with 8 over 4x plus x squared over 4x. So we just multiplied by whatever we didn't have to make them common denominators. Now we can add them together. So that part is now going to equal x squared plus 8 over 4x. So that quantity, remember when we divide by a fraction, it's the same as multiplying by the reciprocal. So we're going to multiply by x over x plus 1. Like always, we can cross-reduce. There's not much to cross-reduce here. Notice we have an x to the first power and an x to the first power, and they're within themselves, so they're monomials. So we can cancel those out. Well, that's going to leave you with x squared plus 8, because you're multiplying everything by 1, over 4 times x plus 1. And now we have our last step. There's nothing we can do to our numerator, so that's just going to remain x squared plus 8. And our denominator, however, we can distribute the 4. So we end up with 4x plus 4. And you have successfully simplified a complex fraction. Try these next two on your own. When you return to the video, the answer will be revealed below for both of them. So this first one, notice how we're missing a 2. So we need to multiply our numerator and denominator by 2. Then we can add, leaving us with 3 over 2x, times, so we're going to multiply by the reciprocal. We have x minus 2 over x plus 4. So 3 times x minus 2 and 2x times our x minus 4. And distribute, and your final result. For B, this one was a little bit easier. You didn't have any addition or subtraction to have to worry about in terms of fractions. So we had 20 divided by x minus 1 divided by 6 divided by 3x minus 3. So multiply by the reciprocal, and then we can cross-reduce. So when we cross-reduce, we could have cross-reduced with the 20 and the 6, but I found that it might have been a little faster because it's really easy to go, okay, 20 times 3 is 60, divided by 6 is 10. You could have done that any which way you would have chosen to do so. Either way, it would have ended up with 10 in the end. So now let's try a transportation application. A freight train averages 30 miles an hour traveling to its destination with full cars and 40 miles an hour on the return trip with empty cars. What is the train's average speed for the entire trip? So here's the breakdown. Your total distance is 2d, because you're going there and back. And then your total time, you're going to have d divided by 30 plus d divided by 40 for the train going there and the train coming back. Now the average speed is when you take your total and divide it by the sum of your parts. So we've got this right here. So we've got our total on the bottom here, and we're going to find our average speed. Now to do so, we need to simplify. So we want to simplify this fraction here, and try that on your own. So you're going to follow the same rules that we've been doing, and when you return to the video, the answer will be revealed over here. So we multiply by our least common denominator, or LCD here, and when we do so, we end up with 240d over 4d plus 3d, and we continue to simplify, leaving us with about 34.3 miles per hour. And that ends our video lesson on adding and subtracting rational expressions.